All right, campers, we're back with the fifth installment of the media computation videos. Today we're going to talk about more about manipulating pictures and arrays and different kinds of loops. So I'll come back here. There we are. And so first thing we'll do is we'll look at a while loop. Now I've talked a little bit about this when we were doing some clicker questions in class, but I wanted to be a little more formal about this. Here's a while loop. So a while loop is a way to repeat a block of statements. A while loop is an example of a pretest loop, just like a for loop is. While loops declare and initialize variables. They have a test, and as long as the test is true, they'll enter the body of the loop, and they'll execute the body of the loop. And then when they're done with that, they will change the loop control variable and then loop back and do the test again. As soon as the test becomes false, then they will exit from the loop and then continue with the program. So both for and while loops are pretest loops. They all have the same format. This is exactly what happens in a for loop as well. You declare and initialize the loop variable. In a for loop, you say for int I equals 0, and then you say I less than 10, for example, as the test. And then you do something. And then at the top of the for loop, there's also an I++ to change the loop control variable. As long as the test continues to pass, you'll execute. And as soon as the test becomes false, you'll exit. So let's do a while loop, and let's examine the problem of adding all of the numbers from 1 to 100. So now how would you do that? Think about that for a second. Okay, so here's my solution. I would initialize my counter. This is my total. This is where I'm going to put the sum of those 100 digits. And then I would initialize a counter, and I'll start with 1. And then I go the test and repeat part. As long as the counter is less than or equal to 100, I'm going to execute the body of the loop, which is to increment the total by the counters, because I'm going to sum all of those numbers between 1 and 100. And then I increment the loop control variable at the end and go back and do it again. Piece of cake. So now, what about if we want to make it more general and we want to add up all the integers starting at some variable start until we get to some other variable end? How would we do that? To do that, we should go over here to BlueJ, and we'll open this. And so here's this little class that I created. If you had an instance variable, they would go there. Constructors would go here. Really nothing to do here, but it's usually good to get into the habit of putting a constructor in your classes. And so now for main, I've got a method that will add the first 100 numbers, and it will then print out the result. And then I've got a method that will do a range of numbers and print out the result. We haven't written that one yet, so if we compile this and then execute it, you'll see that the sum of the first 100 integers is 5,050, but then the sum from 101 to 134 is 0, and that's because we haven't written anything yet. So let's go write something. So here's the adding first 100 numbers. It looks exactly like what was on the slide. But now here we have to add those numbers between start and end. So how would we do that? Well, let's see. So we'll need a counter. Okay. Actually, we could use start as the counter, because we're going to assume, oh, that's something we should put in here. We're going to assume that at the beginning, that, oops, can't type, that start is less than end. Okay, so we'll assume that at the beginning. If that's the case, then start can be our loop control variable. And we can just say while start is less than or equal to end, then we just do exactly the same thing we did up here. We can say sum plus equals start. And then we can say start plus plus. And we can do that, and then we can return some. Notice that this method returns something. In fact, both of these methods do. And so the return type in this case is long. That's just in case I put in a particularly big number. And so it will return a long. In this case, up here, I returned an int. But now that this works, then this should work. And I should be able to get the sum between 101 and 134. How about if we do 101 to 200? Make it a little bigger. And we'll compile. Didn't get anything wrong. And we'll test again. And there you go. The sum of the numbers from 1 to 100 is 5,050. The sum of the numbers from 101 to 200 is 15,050, which you can check out yourself if you'd like. Okay, so back to here. Just to refresh your memory, remember that we can, if we're adding just 1, we can have shortcuts to index plus plus or plus plus index to add 1. And then to subtract 1, we can do index minus minus or minus minus index. And then, of course, there are the assignment shortcuts. We used one for sum, so sum plus, or counter in this case, plus equals 3. But then you can also use assignment shortcuts for minus equals, times equals, division equals, and mod equals. All right, so let's move on to, I did that already. Let's move on to red. So in the last video, we wrote a method to decrease the amount of red in a picture. This time what I'd like to do is I'd like to increase the amount of red in a picture. So what if I want to increase the amount of red in a picture by 30%? Okay, so how would you do that? Think about that for a second. Okay, so if you recall, dividing by 2 or multiplying by 0.5 reduces the red by 50%. So if that's the case, here we are, multiplying by 1 would keep the same red value. Multiplying by 1.3 would increase the red by 30%. And multiplying by 1.7 would increase the red by 70%. And so we could do that, but wait. Why do we need a method to decrease red and increase red when we could just have one method? Because if we go back here, we can see that all we're doing is multiplying here, but we're multiplying by a different factor every time. And if the factor is less than 1, greater than 0 and less than 1, we're going to reduce the amount of red. And if it's greater than 1, we're going to be increasing the amount of red. So instead of having two methods, one to decrease and one to increase, we could just have a single method to change the amount of red in the picture. And so we can do that by going back here. And so now we have this method, this class I'm calling red sunsets, because we're going to do another example in a minute. First thing we're going to do is we'll go create a new picture. Object will show the picture object. We can show you that decrease red works. So decrease red just does what you think it would. In fact, I'm going to change this, and I'm going to change this to int red times 0.5. So just to be consistent, and it should do exactly the same thing as dividing by 2. If there's a fractional part, it'll get truncated because we'd do the cast to int. So if I compile that, oops, possible loss of precision. Oh, right. Java associates the cast with the closest variable, which is red. So in order to make the cast work, I have to put the entire computation in parentheses. And now what it'll do is it'll take this value and then assign that to a type int. So that should take care of that error. Yes. And now we'll come back here and we'll run this there, and it should pop up and ask me for a picture. And well, here's media sources, and we'll do Eiffel elevator. Red to begin with, and 2 seconds later, much less red. Okay, because I reduced the amount of red by 50%. And so that works just fine. So we're good there. Now let's go back, and we need to write the method to change the amount of red. So here's what I wrote to change the amount of red. It does things very similarly to the decrease red, but there's a couple of gotchas in here. So the first thing we do, of course, is we take the picture and we grab all of the pixels from the picture, and we put them in an array of pixels. So we say p.getPixels, and then we add that to the array. We create a variable red to hold our value, and then we enter the loop. Now this is yet another different kind of loop. This is known as a for each loop. It looks very different, and I actually wish they had used the word for each instead of for. What happens is you take a list of something. It's actually a collection of things. In this case, for us, it's an array or a list of all these pixels. And this says you grab one pixel at a time from this list, and that pixel will be named px. And so this for loop will just go through the entire list. You only use a for each loop when you want to start at the very beginning of the list and go to the very end without interruption. Okay? If you only want to do part of the list, you can't use this. But if you want to use the entire list, you can use a for each loop. So for each pixel in the pixel list, we're going to grab the red from the pixel. We're going to multiply this fraction, whatever that is, it could be a number bigger than 1, times the amount of red in the picture. That will truncate the fractional part and make this an int again and stuff it into there. But now, well, this is an important thing. We don't have to do this, but it's an important thing to think about, which is it's called defensive programming. If the fractional part is less than 0, the coder makes a mistake, and if this is less than 0, that's perfectly fine, and this would work, but then you'd end up with a value which is less than 0 for the value of red, and we know that's wrong because the red value for red is only from 0 to 255. So the first thing we do here is we test to see if the value of red is less than 0. If it is, we set it to 0. Okay, because that's obviously going to be the intention of the person who wrote this. Then we have to look at the other extreme. Say that the amount of red in a pixel is 200, and say that somebody used 2.0 as the fractional part here, the factor. And so then that would be 200 times 2, which is 400, which is also too big. And so if red is bigger than 255, we reset it to 255, which is the maximum value for red. So this little if then else is a defensive piece of programming to make sure that the value of red is in the correct range for that color component. And then we just reset the pixel value, and we keep doing this again and again and again. And the for each loop will guarantee that we do it for all the pixels in the picture. Okay? So since that's the case, we can go up here, we can close that, and we can change red. And we will increase, in this case, the amount of red by 50%. And so we'll compile this. We didn't make any mistakes. Go away. And we'll pick a different picture this time, I think. Oh, it's doing this again, is it? Okay, well, we're going to have to reset the Java virtual machine. Done. And then we'll try this again. Okay. And there we go. Dropbox. Dink dink. Media sources. And how about beach? Why not? 2, 3, 4, thunk. And we just we increase the amount of red in that picture by 50% by doing that. Now, because of this, we can do anything we want. In fact, let's do this. I'll also do this just to make sure. There. What we'll do is we will make this number minus. Okay, so that they'll all end up being negative. All the reds will end up being negative numbers. And what that will do, well, that will force us to do, since all of our values will be negative, it'll set all the reds to 0, get rid of all of the red in that picture. And let's try this again. And Dropbox, dink dink, media sources, and we'll try the beach again. So watch the beach. So here's the beach. 1, 2 seconds later, thunk, all the red is gone, and all you see is blue and green. So, all right. So we can do both of those things quite easily. And now, since we're on the beach, let's fake a sunset. So say we have this nice picture of a beach area, and we would like to make it look like it's close to sunset. It's sort of a red haze in the sky and all of that jazz. And because after all, we're going to be making Photoshop here soon. So how would you make the beach appear to be at sunset? It clearly looks like what you should do is increase the amount of red, right? So we could try increasing the amount of red, and we can already do that by using it. Actually, we can't because we don't have an increased red here. Oh no, we can use change red. So let's do change red, and let's say that we increase not by 0.5, but let's say we increase the amount of red by 0.3, okay, by 30%, and we'll compile. And we will pick that beach picture again. And we'll see if that works. And well, there. It's the beach picture. 1, 2, 3, dunk. And that didn't work that well. And also, the other thing that happens, of course, is that we get red highlights here, but no red highlights there. So that's just not a particularly satisfying result. But there's another way to do it. Instead of, if we go back, instead of increasing the amount of red, what if we decrease the amount of blue and green? Because you could think about it as sunset, the sun is going down, and it's decreasing the amount of light in the scene, and so the amount of blue and green would be decreased. So what about doing that? So we reduce the blue and the green by 30%, So we get, or by some percentage, we get the array of pixels, we have this loop, we get the pixel, we set the blue value to 0.7 times the original, we set the green value to 0.7 times the original, and we increment the index and go back. Okay, so that's pretty easy to do. So let's go back to BlueJ here, and we'll scroll down. And so here's a sunset. And so put our code here. So let's try this. So we're going to need, actually I'm going to grab these. Grab. And I'm going to put them there. So now I have those two things. I'm going to pass in, so I'm not going to restrict myself to 30%. I'm going to pass in a percentage, and I'm going to say fraction. Oops, I guess I needed to be double. Double fraction equals 1.0 minus percent divided by 100.0. Okay, and so that will take the percent. It'll divide the percent by 100 first, because division is higher priority than subtraction. And this will convert the percent to a double. It'll divide by 100, and so 30 will go down to 0.3. We'll subtract that, and that result will be 0.7, which will get put in here. And then we'll have for int, int I equals 0, I is less than pixels dot length. So we'll do all of them, I plus plus, do that. And then we will say, let's see, we will say that, pixel, actually we don't need this guy, do we? We don't need that guy, because what we'll do is we'll say pixels sub I dot set red pixels sub I dot get red times fraction. And actually what we'll do is we'll put this, we'll say int, we'll put that in there, and we'll put that in there. And actually that's all we have to do in our loop. Alright, because we grab the amount of red in the pixel, we multiply it by the fraction, we make it back into an int, and then we reset the value in the pixel. And that's it. That should do it. Let's try that. Let's try make sunset. Okay, so we come up here, and we're going to do this, and then we're going to do make sunset p comma 30. Okay. That's just decreasing the amount of red. Well, we'll see how this doesn't work. Compile. And Dropbox. Thunk thunk. Media sources. Beach. 1, 2, thunk. Okay, yeah, see, and that's the unsatisfying version. So let's go back and change that, because we wanted to decrease the amount of green and blue, not the amount of red. And so we'll come down here again. And instead of doing this, this will be green. And this will be green. And then this will be actually this line. Oh, come on, really? There. Copy, paste, and then this will be blue, and then this will be blue, and we're going to be changing the values of green and blue. We're going to be reducing the values of green and blue. And that worked, and go away. And so let's try that. And it's still going to be 30%. Dropbox. Thunk, thunk. Media sources. Beach. Thunk. See, that now moves it decreased the amount of green and blue, so there's more red highlights, and the more red highlights in particular, you can see them here. It almost looks like that shadowy, that reddish hint that you get when the sun is really low in the sky. This is a much better picture, a much better version of a sunset than the original one. Okay, so now that we've got that done, we're done. There is another version of Make Sunset down here, and it uses a different kind of factor here, and this one uses a percent, so you have to do the division. This one just uses a 0.5 or 0.3 or 1.2 or something like that. But notice the interesting part here is that the signature of this Make Sunset and the signature of this one, notice that these two methods have the same name, Make Sunset. But Java is okay with that because they have different signatures. They both are public static void, and they both take a picture, but this one takes an int, and this one takes a double. So the signatures of the two methods are different, and that's okay. That's called overloading a method name. I'm using the same method name for the same thing, but I have two different signatures. So, and that's perfectly legal in Java. You notice it allowed us to compile. We had no problem whatsoever. So, all right, so that's it for now. Take care. Talk to you later.